Hi everyone, I'm Arya, an electrical tutor working with EWRB. Today I would like to start this audio review questions series to go together with the audiobook based on the EWRB Electrician teaching guidelines. Please listen to the audiobook first, then use this audio review to test your understanding. Let's get started. Hi everyone, I'm Arya. Let's start our topic review. Before we begin, I just want to mention one thing. These review questions may contain mistakes. If you notice any mistakes, please point them out in the comments. I will double check them. If anything is corrected or updated, I will add the fixed questions in the video description below this video. So, when you listen to this audiobook, please check the description first. Thank you. Now, let's start. Topic 16: Selection of cables. Review question 1. What is the main purpose of the cable selection process? Option A. To choose the cheapest cable. Option B. To choose a cable that is safe and compliant under all conditions. Option C. To choose a cable based only on conductor size. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Cable selection is a design process. The cable must carry the load without overheating, suit the installation method and environment, meet voltage drop limits, allow protective devices to disconnect in time, and survive fault energy until the device operates. Review question 2. What does current rating of a cable mean? Option A. The maximum current the cable can carry continuously without overheating. Option B. The fault current the cable can carry for one cycle only. Option C. The current the cable carries only at startup. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Current rating is the continuous safe current under stated conditions. If the cable carries more than its rating, insulation temperature rises, aging accelerates, and failure risk increases. Review question 3. Why must the cable voltage rating match or exceed the supply voltage? Option A. To reduce cable cost. Option B. To prevent insulation stress and breakdown. Option C. To increase current capacity automatically. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. If the voltage rating is too low, the insulation can be overstressed, leading to partial discharge, tracking, or breakdown, especially during surges. Review question 4. Which factor most directly increases voltage drop? Option A. Shorter cable length. Option B. Lower load current. Option C. Longer cable length. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option C. Voltage drop increases with length because the cable impedance acts over a longer distance. Under load, more voltage is lost along the conductor, so the equipment receives less. Review question 5. If the load current increases, what happens to voltage drop in the same cable and length? Option A. It decreases. Option B. It increases. Option C. It stays the same. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Voltage drop is linked to current through the cable impedance. Higher current causes a larger drop, which can affect motors, lighting performance, and appliance operation. Review question 6. Why do we check earth fault loop impedance when selecting a cable? Option A. To make the cable lighter. Option B. To ensure protective devices disconnect fast enough under fault conditions. Option C. To reduce normal running current. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. A low enough loop impedance allows sufficient fault current to flow so the fuse or breaker trips within the required time. If impedance is too high, the fault current may be too small and disconnection may be delayed. Review question 7. Which change usually increases cable operating temperature the most? Option A. Better ventilation. Option B. Installing the cable where heat cannot escape easily. Option C, using a larger cable size. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. When heat cannot dissipate, the cable runs hotter for the same current. That reduces allowable current carrying capacity, so derating is needed. Review question 8. What is the purpose of applying derating factors? Option A. To increase the cable current rating. Option B. To adjust the cable rating to match real installation conditions. Option C. To avoid doing voltage drop checks. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Tables usually assume standard conditions. Rail sites may have higher ambient temperature, grouping, insulation, or enclosure. Derating reduces the allowable current to keep the conductor within safe temperature limits. Review question 9. What does grouping of cables typically do to current carrying capacity? Option A. It increases capacity because cables share heat. Option B. It has no effect. Option C. It reduces capacity because cables heat each other. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option C. Grouped cables cannot lose heat as well because each cable warms the area around the others. That raises conductor temperature, so the allowable current must be reduced. Review question 10. Which installation method usually allows the best heat dissipation? Option A. Cables clipped in free air, where air can circulate. Option B. Cables tightly enclosed in conduit and insulation. Option C. Cables buried in warm soil with no spacing. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Free air circulation improves cooling. Enclosed or insulated installations trap heat and usually require stronger derating. Review question 11. Why do cables installed in conduit often have a lower current rating than clipped cables? Option A. Conduit increases conductor resistance. Option B. Conduit restricts heat loss from the cable. Option C. Conduit increases the cable voltage rating. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Conduit limits air movement and traps heat. Even though the conductor is the same, poorer cooling means the cable reaches its temperature limit at a lower current. Review question 12. Which statement best describes prospective short-circuit current? Option A. The normal operating current of the load. Option B. The maximum fault current available at a point in the installation. Option C. The current rating written on the cable drum. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Prospective short-circuit current is the fault level available from the supply and installation impedance. It is used to check breaking capacity of devices and short-circuit thermal withstand of cables. Review question 13. Why must a cable's short-circuit capability be checked? Option A. To ensure the cable can handle fault energy until the protective device clears the fault. Option B. To reduce the cable length required. Option C. To avoid using earthen conductors. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. During a short circuit, current can be extremely high. Even for a short time, I2T heating can damage insulation or cause conductor deformation unless the cable can withstand it until the breaker or fuse operates. Review question 14. What is maximum demand used for in cable selection? Option A. To estimate the realistic highest load likely to run at the same time. Option B. To add all appliance nameplate currents with no diversity. Option C. To decide the color of the cable sheath. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Maximum demand is the expected peak load after applying diversity. It helps size mains and submains so they carry realistic peak loads safely without oversizing everything unnecessarily. Review question 15. When selecting mains and submains, why are the stakes higher? Option A. They usually supply multiple circuits, so an error can affect the whole installation. Option B. They never require protective devices. Option C. They never require voltage drop checks. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Mains and submains often carry larger currents and longer runs. If they are undersized, you can get overheating, excessive voltage drop, and poor fault disconnection across many circuits. Review question 16. Which cable type is typically chosen where movement or flexibility is required? Option A. Fixed TPS in walls. Option B. Flexible cables such as PVC flexible, TPS flex, or rubber sheathed. Option C. Neutral screened, underground cable only. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Flexible cables are designed to bend repeatedly without damage. Fixed wiring types are not intended for frequent movement and can crack or fail at terminations. Review question 17. Which option best describes fixed wiring cables? Option A. Only used for portable tools. Option B. Used for permanent installation methods like TPS, conduit wire, XLPE, armored or screened types. Option C. Only used for temporary leads on sites. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Fixed wiring is installed as part of the building or plant. It is selected for the environment, mechanical protection, and installation method, and then protected by suitable devices. Review question 18. Which cable family is commonly used underground due to mechanical strength and moisture resistance? Option A. Neutral screened or XLPE underground types. Option B. Light-duty figure 8 aerial only. Option C. Thin flexible appliance cord. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Underground environments can be wet and physically demanding. Screened or XLPE types are commonly chosen because insulation and construction better suit burial conditions and protection needs. Review question 19. Why do aerial cables need special consideration compared with indoor cables? Option A. They are never affected by temperature. Option B. They can be exposed to UV, wind movement, and weather, so construction must suit those stresses. Option C. They do not carry current. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Aerial cables face sunlight, temperature swings, vibration, and mechanical load. The cable must handle these without insulation cracking, sheath damage, or conductor fatigue. Review question 20. Which conductor material is most common in general building wiring and why? Option A. Copper, because it has low resistivity and good mechanical and termination performance. Option B. Aluminium, because it always carries more current for the same size. Option C. Steel, because it is the best electrical conductor. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Copper has lower resistivity than many metals used in wiring, giving lower losses and voltage drop for a given size. It also terminates well when installed correctly. Review question 21. If aluminium is used as a conductor, what must you pay special attention to? Option A. It never needs special terminations. Option B. Correct lugs, terminations, and installation practices suitable for aluminium. Option C. It eliminates voltage drop completely. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Aluminium can require specific connectors and careful workmanship to maintain reliable low-resistance joints. Poor terminations can overheat and fail. Review question 22. What does maximum conductor temperature mainly depend on? Option A. The insulation type and cable construction. Option B. The color of insulation. Option C. The time of day. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Insulation has a temperature limit. The cable current rating is set so the conductor stays below that limit under the installation conditions, protecting insulation life and safety. Review question 23. If ambient temperature rises, what happens to allowable cable current carrying capacity? Option A. It increases. Option B. It decreases. Option C. It stays the same in all cases. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Higher ambient temperature leaves less cooling margin. The conductor reaches its maximum temperature at a lower current, so derating is required. Review question 24. Why is mechanical protection part of cable selection? Option A. Because mechanical damage can expose live conductors and create faults. Option B. Because mechanical protection only affects appearance. Option C. Because it increases voltage rating automatically. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Impact, abrasion, crushing, or digging can damage insulation. Good selection includes choosing the right cable type and route, or adding protection like conduit, covers, or armor where needed. Review question 25. Which situation most strongly suggests the need for a tougher cable construction or protection? Option A. Cable hidden and protected inside a wall cavity with no exposure. Option B. Cable exposed where it may be hit, crushed, or abraded. Option C. Cable that is never energized. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Where physical damage is likely, you may need a more robust cable type, better routing, or additional protection to keep the insulation intact and prevent faults. Review question 26. What is the correct order of thinking for selecting a cable for an application? Option A. Pick any cable size first, then hope the protective device suits. Option B. Identify load and conditions, choose installation method and cable type, apply derating, then check voltage drop, loop impedance, and short circuit capability. Option C. Only check voltage drop and ignore the rest. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. This structured process prevents missed checks. Each step confirms the cable is safe in normal operation and during faults, and that the protective device can do its job. Review question 27. Why do we still do a voltage drop check even if the cable can carry the current safely? Option A. Because voltage drop affects equipment performance and may breach allowable limits. Option B. Because voltage drop only matters on DC circuits. Option C. Because voltage drop replaces earthing requirements. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A cable may be thermally fine but still drop too much voltage over a long run. That can cause dim lights, motor starting issues, nuisance tripping, or equipment not operating within design limits. Review question 28. What is one likely result of excessive voltage drop on a motor circuit? Option A. The motor may struggle to start and may draw higher current for longer. Option B. The motor becomes more efficient. Option C. The protective device rating increases automatically. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Low terminal voltage can increase starting time and heating. Longer high current start can stress both motor and cable and may trigger protective devices. Review question 29. What does earth fault loop impedance is low enough practically mean during a fault? Option A. Fault current will be high enough to operate the protective device quickly. Option B. Fault current will be too low to be noticed. Option C. The circuit will keep running normally. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A low impedance loop provides a strong fault current path. That rapid current rise helps the fuse or breaker trip, reducing touch voltage duration and fire risk. Review question 30. Which statement about protective devices and cable selection is correct? Option A. The protective device rating must never exceed the cable's allowable current after derating. Option B. The protective device rating must always be higher than the cable rating. Option C. Protective devices are chosen without considering the cable. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. The protective device must protect the cable from overload. If the device allows more current than the cable can safely carry under real conditions, the cable may overheat without the device operating. Review question 31. Besides overload protection, what else must a protective device achieve for cable safety? Option A. It must disconnect fast enough during faults to limit damage. Option B. It must increase voltage drop. Option C. It must reduce maximum demand automatically. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Faults can create huge currents and heating. The device must clear the fault quickly enough so the cable's short circuit withstand is not exceeded and nearby materials are not ignited. Review question 32. Why is breaker curve or tripping behavior relevant to cable selection? Option A. It affects the disconnection time under fault conditions. Option B. It changes the conductor material. Option C. It removes the need for earthing. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Different devices trip differently at the same fault current. You must ensure the expected fault current will make the device trip within the required time so touch voltage and heating are controlled. Review question 33. In an installation with multiple cables grouped together and surrounded by insulation, what must you expect? Option A. Higher allowable current due to better cooling. Option B. Lower allowable current due to reduced heat dissipation. Option C. No change to current rating. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Grouping and insulation trap heat. The cable will run hotter, so you must apply correction factors and may need a larger conductor size to carry the same design load safely. Review question 34. What is the main reason we consider the length of run during cable selection? Option A. It affects voltage drop and may also affect fault loop impedance. Option B. It changes the supply frequency. Option C. It changes the color of the insulation. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Longer runs increase resistance and impedance. That raises voltage drop under load and can reduce fault current, which can slow protective device operation. Review question 35. Which statement best describes installation method in cable selection? Option A. It only means whether the cable is red or black. Option B. It means how the cable is run, such as conduit, tray, clipped direct, underground, or aerial, which affects thermal and mechanical performance. Option C. It means which retailer sold the cable. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Installation method changes cooling and protection. The same cable size can have different allowable currents depending on how it is installed and what surrounds it. Review question 36. Why might underground installation reduce current carrying capacity compared with free air? Option A. Soil can limit heat dissipation, and conditions vary with moisture and temperature. Option B. Underground cables do not carry current. Option C. Underground always provides perfect cooling. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. Soil can act as insulation depending on type and moisture. If heat cannot escape, conductor temperature rises, so the allowable current may be lower and derating may apply. Review question 37. When selecting a cable, which combination is most correct? Option A. Current rating only. Option B. Voltage rating only. Option C. Current rating, voltage rating, environment, installation method, derating, voltage drop, loop impedance, and short circuit performance. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option C. Cable selection is multi-factor. Missing one check can cause non-compliance or unsafe operation, even if the cable looks big enough. Review question 38. What is a common mistake when sizing cables for a job? Option A, following a structured process. Option B, choosing a size from a table without applying correction factors or checking voltage drop and fault performance. Option C, confirming installation conditions first. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option B. Tables assume specific conditions. If you skip derating, voltage drop, and loop impedance checks, the cable may overheat, equipment may undervolt, or protective devices may not trip fast enough. Review question 39. Why is cable selection described as systematic? Option A, because each step confirms safety in normal operation and in fault conditions. Option B, because it always gives the same cable size for every job. Option C, because it removes the need for testing. Pause. 5, 4, 3, 2, 1, 0. Correct answer is option A. A systematic approach prevents gaps. It links load assessment, installation conditions, protective device choice, and the key checks that prove the design is safe and compliant. That finishes the Topic 16 review. Listen again, choose an option, wait for the countdown, and check your understanding.